Hi everybody, I figured today would be a good day for a Zoom break, so we have two things on the agenda. First is we're going to look at new notation for transformations, and then two, we're going to incorporate two new graphs into our repertoire. But really, we can apply these transformations to any graphs I give you, but I just want to do two today because I don't want to overwhelm you guys. So first thing, let's look at this new notation, okay? Given that the function f of x equals x squared, so they're stating, hey, this is the parent function. Okay, graph the transformed graph of f of x plus 4 minus 3. There's no equation, right? There's no equation, but there is this notation. And this still matches the rules that we've been doing, okay? If you go look at your notes right now to your rules, this x plus 4 should look like this one that we wrote for h. Hey, that's my h value. Awesome, okay? If you go to your rules for that minus 3, that should look like this, right? Remember, I didn't give you a function when we wrote the rules. I said it could be any function. So what I'm saying is it's x squared minus 3, okay? That's what I'm saying. That's what this notation is saying. This x plus 4 is saying it's x plus 4 squared like that, and our minus 3. So this really is our equation. We don't need to write the equation, but we could figure it out, right? So let me go ahead and erase this. And let's look at the plus 4 and the minus 3. So we know that we are just translating this. We're just translating this. So this is going to go to the left 4. Well, that's supposed to be an arrow. And this is going to go down 3. Okay? So 3 down, 4 left. Okay? Now, I'm writing this shorthand, like I'm not saying a vertical translation or a horizontal translation, because I didn't ask to describe the graph. This is for me to reference. Hey, I'm going to go 3 down, I'm going to go 4 left. If I were to say, hey, formally describe it, it's a good idea to say the translations, vertical translation, horizontal translation. Okay, let's graph the parent function. Well, you know the parent function, we've been graphing it all week. And I'm just going to count. You can totally make your tables, but I'm just going to count. I like to start over here to the left. Negative 2 comma, oh, those are the wrong points. I do that. Sometimes I go to 3 and not 4. That's better. There we go. Okay. So negative 2 comma 4. I'm going to go 4 left and then 3 down. So 1, 2, 3, 4, 1, 2, 3. Okay. This negative 1 comma 1. 1, 2, 3, 4, 1, 2, 3, right there. 0, 0, 1, 2, 3, 4, 1, 2, 3. Hey, look, there's that left side curve right there. Okay, looking good. 1 comma 1, 1, 2, 3, 4, 1, 2, 3. Hey, we're rounding out the curve. And then the last one right here is 1, 2, 3, 4, 1, 2, 3. There is our graph. Perfect. This is plenty of work right here for this question. Okay, the a value is 1, so I don't have to multiply. So just count the translations. Okay, but I want to apply this to some new graphs. Okay, let's apply this to some new graphs. So let's go all the way down here. And look, my new parent function is x cubed. You may not know what x cubed looks like, but you know it's a parent function. So you know it's going to live somewhere around the origin. Okay, there's a reason why whenever I make my table for my parent function for quadratics, I do negative 2, negative 1, 0, 1, 2. That creates my curve around the origin. So why don't we use that same idea? Let's use those same points, okay? And see what this graph looks like. Sorry, I'm trying to erase. Okay, so I'm taking these points and I'm plugging them into the function. I'm going to take negative 2 and plug it into x cubed. So negative 2 cubed is negative 8. Negative 1 cubed is 1. Negative 1, sorry. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. Let's graph it, see what it looks like. Here, 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 and here. That's a cubic graph, okay? Hopefully you've seen this graph before. If not, no worries. I just got these points because I thought, hey, let's get some points around the origin. I know it's a parent function, so I know it's going to live around the origin, okay? Now let's apply the transformations to it. It's going to go to the left 2, and it's going to go down 4. I should say left 2 instead of just an arrow. It's going to go left 2 and down 4. Let's count. Okay, let's start up here. So I'm going to go 1, 2, down 4. 1, 2, 3, 4. Okay, this point right here, this negative, this 1, 1, 1, 2, 1, 2, 3, 4, right there. Okay, this point right here, we might get a little confused with the points. I'm going to change the, that's too close to, let's use yellow. The new points to yellow just because it's getting a little confusing because I'm hitting dots. This point right here at -1, -1, I'm going to count 1, 2, 1, 2, 3, 4. Let's use yellow. Okay, did I skip 0? I think I skipped 0. I did, yeah. 0, 0, 1, 2, 1, 2, 3, 4. There we go. That gives us that little 1, 2, 3. So here's the top curve, and I start to curve down. Perfect. Then this last point right here, okay, is 1, 2, and then it's going to go off the page, but that's okay. 1, 2, 3, 4. So something like that. This is our new graph. Notice I'm making sure I put arrows on it. Okay, so I just created a table and I graphed it. Okay, let's try one more. Absolute value. I'm hoping you've seen absolute value before, but if not, again, I just want to get some points around the origin. Okay, sometimes they won't work, and you'll see next week when it doesn't work, but today they should work. So there's the points around the origin. I'm plugging these x values into the function. So the absolute value of -2 is just 2. Absolute value of -1 is 1, 0, 1, 2. Okay, so this is our parent function. Let's graph it. So -2, 2 is right here. -1, 1, 0, 0, 1, 1, 2, 2. So this is kind of like a quadratic, but it's the graph that comes to a point. I'm hoping this looks familiar to you. Okay, now let's perform our transformations. Hey, I got an a value this time. Same idea, multiply it to the y values. Nothing's different, just the parent function, okay? But the rules still apply. So I get -4, I get -2, I get 0, I get -2, and I get 4. -4, sorry. There should be a stretch, a vertical stretch, and a reflection, okay? Vertical stretch and reflection from that -2. So I'm going to get -2, 4. I'm going to get 1, -2. I'm going to get 0, 0. Sorry, I'm getting a little... sorry, I didn't go far enough. -2, 4. That looks better. There we go. That looks better. And I'm going to get 1, 2, -2, I should say, and then 2, -4. So this is my reflection and my stretch. Notice how it got more narrow. It's exactly what we want to happen. It got more narrow. But I still have a -4. It means I got to go to the right 4. So right 4. Okay, it's a horizontal translation to the right 4. So I'm just going to count. 1, 2, 3, 4. This point right here, 1, 2, 3, 4. This point right here, 1, 2, 3, 4. This point, 1, 2, 3, 4. Look, there's my V, right? Okay. Oh, and that line made down 2, right? And this point, 1, 2, 3, 4. There we go. There's all the points. There's a stretch, a reflection, and a translation. Awesome. Okay, so the only new graphs are going to be cubic and absolute value. We'll do more next week. So please complete the questions that I'm posting, and then we'll go over them next week. Have a great day, guys. Hope you enjoyed the Zoom break. Bye.